Hello everyone, I am Vishal Soni. Today we're gonna analyze and modify this mini cooler. I have got this mini cooler from one of my friend. He said this is no longer working properly. You can say this is a toy cooler. This is not able to cool down your room, but you can cool down your face or your armpit. As you can see, it has two flaps to choose the direction of cooler. It has a bottom container to keep some ice. This is the switch to on off the cooler. It has 3 nickel cadmium cells. Each cell can provide 1.2 volt and all cells have capacity of 1000 milliampere per hour. The cooler comes with this type of cable. We don't have the cable, so I have made this myself. The other end is USB and the end which is go into the cooler is DC jack. As you can see, I have opened the VCC terminal to measure the current at charging. I am using this 5 volt 2 ampere adapter which is not made in China. As you can see, we have multimeter and our cooler. Now we will insert the charger and measure the current at opened VCC terminal. Now set the multimeter at current settings. Change the probe hole and set the meter at 10 ampere. Now we will connect our probes at VCC in series. So you can see there is no reading in multimeter. So we will check the charger, maybe there is problem. I have connected black probe at ground, which is outer surface of DC jack, and red probe at VCC, which is our open terminal. As you can see, we are getting around 4.9 volt, which is 5 volt. So charger is correct. Maybe some problem is in multimeter. So we will check this. Let's test our multimeter are taking correct reading of current or not. So first of all, set the multimeter at 10 ampere. As you can see, turn this to the 10 ampere settings. Black probe should be in middle of your multimeter and red probe should be left of your multimeter. You can see here. This is our adapter and this is our DC jack. As you can see, this is our DC jack. So the outer terminal is ground and inner terminal is VCC. Take a 10 ohm resistor and connect one end at VCC and other end should be connected to the red probe. As you can see, the red probe is connected to the other end of 10 ohm resistor and black probe should be connected to the outer terminal of DC jack, which is ground. Now take the multimeter. As you can see, there is 0 readings in multimeter. Now take our DC jack and 10 ohm resistor. Make sure your 10 ohm resistor have 2 watt of capability because we will draw lots of current. First of all, connect the VCC end which we have opened to measure the current. Now take the 10 ohm resistor. As you can see, this looks pretty big because it has capability of 2 watt. As we all know, according to Ohm's law, V is equal to IR. So we find out the current according to our voltage and resistor. We are using 5 volt adapter, so voltage should be 5 and our resistance is 10 ohm, so we will get 500 milliampere, or you can say 0.5 ampere. Let's connect the resistor to the VCC of our DC jack. Now connect black probe at ground and red probe at other end of resistor. As you can see, I am still not getting anything. Okay, this resistor is loose at VCC. So now you can see the current is around 480 milliampere. Oh, this resistor got pretty hot at this current. So let's check the power. The current difference may be due to some losses. Always theory are different from practical. Now as you know, power is equal to VI, or voltage is 5 and current is 0.5 ampere. So power should be 2.5 watt. So you have to use 2.5 watt resistor to handle the heat. Our multimeter looks fine, then there is a problem in cooler. So let's open the cooler and see what's inside it. We can see there is so many wire, but there are no circuitry here. We have found 3 things: motor, switch and charging jack. Here is circuit diagram. As you can see, this is a charging jack. This is our motor. This is a switch. One wire is connected by a switch and the wire go to the anode of one cell. As you can see, all 3 cells are connected in series. The negative terminal are connected to the positive and positive to negative, which is called series connection. Last negative end connected to the motor as well as to charger. All cells are connected in series, so total voltage are 3.6, but current remains same. So we can say this battery pack can provide 3.6 volt and 1000 milliampere per hour. I have found the problem. This jack has 2 ground and both are connected to each other. One is going to the battery and other one is going to the motor. So when we check the sorting between both 2 grounds, it will show sorted in multimeter. Let's check it. But when I connect the charging jack, it will no longer sorted. Let's check it.
Connection. There is no continuity in it.
So there is a problem in the jack. So I took a wire and I will bound it on both ground so they will not disconnect from behind. So after lots of trouble, we are here again to measure the charging current. Now connect the charging pin to the charging jack and measure the current at the VCC terminal, which we have opened to measure the current. As you can see, the charging current is around 800 milliampere, which is 0.8 ampere. So let's calculate the charging time. Here we have 1000 milliampere per hour of battery and the charging current of 800 milliampere. So the total time taken for the charging is 1.25 hour, which is around 80 minutes. But theory isn't perfect from practical. There are some losses. So let's take 100 minutes to fully charge it. The charging time is completed. Now we will measure the current taken by motor. So we will cut the wire from here, or we can measure from the cell terminal. As you can see, current taken by motor is around 400 milliampere, which is 0.4 ampere. As you can see, my red probe is connected to the anode of cell and black probe is connected to the anode terminal of cell holder. Our motor is taking 400 milliampere, which is 0.4 ampere, and our battery capacity is 1000 milliampere per hour, which is 1 ampere per hour. So let's calculate the discharge time. Our discharge time is around 2.5 hour, but theory isn't perfect as practical due to some losses. So let's take it around 1.5 hour discharge time. Let's power it up to see the actual discharge time. After 15 minutes, this battery is stopped working. It means this battery is completed their charging and discharging cycle, so we have to change it. Instead of nickel cadmium battery, I am using lithium ion battery, which is easily available in market. I have bought it from nearby store. This battery is smaller in size and it has same capability as the 3 lithium cadmium battery. It does not have their data sheet, so I am assuming the 50% of charging current is safe to charge it. I have found this charging module, which is TP4056. It has micro USB port and it is also available in C-type port. The C-type port and micro USB port makes it easy to charge. I have changed the R3 resistor to 3K resistor to set the charging current around 400 milliampere. It has 4 terminals. The P plus and B minus terminal will be connected to the battery, and out plus and out minus will be connected to the motor. Whenever I connect the micro USB to charging module, the blue light lit up. It means your battery which is connected is fully charged or your battery is not connected. As you can see, now is red light lighting up. It means your battery is in charging mode. As you can see, the blue light indicates the battery is fully charged. I have connected the main connector at positive and negative terminal of battery holder. Now we will connect the battery and turn on the fan to check the discharge time. The battery took 1.5 hour to discharge, which is enough for me. Maybe the good quality battery will give you good result. Cover the old charging port hole with some tape and put some hot glue behind this. After this, just remove the tape and you will get a finished surface. As you can see, I have made a hole for micro USB of charging module, and there is two small hole for red and blue LED, and I have fixed the charging module with help of hot glue. If you don't realize the circuit is very simple. This is our charging module, and the B plus is connected to the positive of battery and B minus is connected to the negative of battery. Out plus is connected to the motor through a switch, and out minus is directly connected to the motor. As you can see, all looks good. Now we will insert the micro USB, and red LED indicates the battery is charging. I hope you have learned lots of things in this video.